Hello everyone, and thanks for joining me. In this video we're going to take a look at another example where we want to calculate internal rate of return for a project. This one says a local firm sponsors a student loan program for the children of employees. No interest is charged until graduation, and then the interest rate is 5%. Maria borrows $9,000 per year at the beginning of each year, and she graduates after 4 years. If Maria makes 5 equal payments, how much is each payment? And then what is the IRR of Maria's loan? So what happens is no interest is charged until graduation. And for student loans, they pay that back after graduation. So these 5 equal payments start at year 5. So let's start by putting everything on a cash flow. Well, the problem says Maria borrows $9,000 per year at the beginning of each year. And remember, the cash flows that we've been working with is end of year cash flows. If she receives at the beginning of each year, the money that she receives at the beginning of year 1 is essentially at the end of year 0. So in order to be consistent with the formulas and the way our cash flow diagram works, we put the first receipt of those payments at the end of year 0, at the end of year 1, at the end of year 2, and at the end of year 3. And remember, these four $9,000 are the same as at the beginning of year 1, at the beginning of year 2, at the beginning of year 3, and at the beginning of year 4. But because the cash flow diagram that we've been working with and the formulas are all based on end of year cash flows, we had to shift the cash flows 1 year before. So here at the end of year 4, she graduates and she starts to pay back the loan at year 5. So starting point of these payments will be year 5, year 6, year 7, year 8, and year 9. And these are 5 equal payments as they describe here in the problem. So the first step is to calculate how much is each payment, those 5 payments that we have here. Well, if there is no interest to charge in the first 4 years, no interest, what happens is all these $9,000 over 4 years are going to accumulate, and at the end of year 4, they're equivalent of $36,000, right? 4 times $9,000. And that is the amount of loan that has to be paid back. So $36,000 here, and starting from year 5, you're paying them back. How do we calculate A here? Well, A is equal to $36,000 times A given P, right? We're looking for A, we have the P. The interest rate during those 5 years here is 5%, so 5% and 5 years. So that A is $8,316 if you calculate that. So we have the A. Now, in order to calculate the IRR of this loan, we have to consider the entire cash flow here, right? There is no interest during the first 4 years, but there's 5% interest in the last 5 years. So overall, through the entire 9 years, what is the IRR of this project? Well, right from the get-go, because there's no interest here and there's 5% interest here, overall throughout the 9 years, the IRR has got to be less than 5% because no interest was charged here and only 5% charged here. So overall, the interest or IRR of this loan is going to be less than 5%. So what we will be doing is to calculate the net present worth of this cash flow at 2 different percentages. in order to get one positive present worth and one negative present worth so that we can do the linear interpolation. So what I'm going to do is to calculate the net present worth of this cash flow at 4% and also at 2%, and then I will do the linear interpolation. At this point, I think it's good to pause the video and calculate the net present worth of the cash flow at those two percentages, 4% and 2%, and do the linear interpolation based on what we learned in the previous example, and then come back to the video. So here, present worth at 4% is equal to, well, here we have a $9,000 at year 0, so that goes right into the present worth, plus we have 3 9,000s in the year 1, 2, and 3, so that is 9,000 times P given A 4% and 3, right? 3 years. There are 3 cash flows here. Minus these payments, present worth of these payments, and that would be minus 8,316 times. How do we take these cash flows back to time 0? Well, that is times P given A 4% in 5 years, and that would create the present worth of these payments at this time, right? Then you would have to multiply it to another factor, and that is P given F, 4% in 4 years, right? Because from here to here, it's 4 years. And that is equal to $2,330.05. You can do the same with present worth at 2%. And the only difference would be these percentages will be 2%, so different factors, and that will give you, if you do the calculations, it will give you $1,257.30. So we have a negative present worth, we have a positive present worth at 2% and 4%. We can do the linear interpolation and find the IRR. Now, if you solve this linear interpolation for IRR, right, you will get IRR of approximately 2.7%. And that is just a linear interpolation, so it's approximation that the IRR is about 2.7%. And that's makes sense because the interest rate on the loan was 5% only during the last 5 years, and there was 0 in the first 4 years. So in general, over 9 years, the IRR has got to be less than 5%, which is about 2.7%. At this point, you might have this question in your mind that how did we try only 4% and 2%, and that was just guesstimates. You would have to calculate them at different percentages in order to get a negative and positive and do the linear interpolation. Another way to calculate this is to, instead of using the factors, you would use the formulas, and then you mathematically solve for that I. And that's a little more tedious mathematically, so that's why I do the linear interpolation.